Okay, when we're looking at proving similar triangles, we have 4 coded reasons that we can use to describe that. So when we're proving our similar triangles, we're looking for 3 pieces of information to prove that those triangles are similar. So when we have SSS, in congruent triangles, that would have told us all the sides, the 3 sides of the triangle were the same on each triangle. However, here we're saying that the scale factor is the same for the 3 pairs of sides. For SAS, instead of the side lengths being the same length on each triangle, here we've got the same scale factor for 2 of the sides, and we know an angle is the same in both. We have our angle, angle, angle. This is one we weren't able to use in congruent triangles because we needed to know that a side length matched. Here we can have angle, angle, angle because we just need the same shape. We don't need them to be the same size like we did for congruent triangles. So angle, 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 if we know that we have 3 angles that match to 3 angles on the other triangle, then we can say it is a similar triangle. The last one is our RHS, which is another one we used for congruent triangles, where we've got a right angle, we have our hypotenuse has the same scale factor, and another side has the same scale factor. So I'm going to go through 4 types and show you how you can do that. So in the first one, we have a right angle. That points us straight towards the RHS rule, but we have to check if we have any other information. So enough to establish that it's a similar triangle. So we've got our angle B and angle E are right angles. Then we have that our scale factor between our BC and EF is equal to, and in this case we're going from a bigger to a smaller, so 2 divided by 4 is 0.5, and then our scale factor for AC to DF is equal to 3 divided by 6, which is 0.5. That now gives us those 3 pieces of information that we needed, so we can say that, I'll bring it over here, triangle ABC is similar, and that's our coded reason for that, or, so we can use the 3 vertical, or we can use 1 wavy line. So we also have to make sure we label in the same direction, so A, B, C, D, E, F, following the same order around the triangle. We can say that triangle ABC is similar to triangle DEF, and our reason is RHS. So that's our similarity statement. The ones that we have down the bottom here, we've got 3 sides given to us. So what we need to do is check that the scale factor is the same for each of those sets of sides. So 5 to 7.5, 7 to 10.5, and 4 to 6. So I'm going to start with the 4 to 6 and do 6 divided by 4. And I get that that scale factor is equal to 1.5. I can then need to do my 7.5 divided by 5. And I can see that my scale factor is 1.5 for that as well. So I've got 1, 2, and then I'm going to check my 10.5 divided by 7, and I get 1.5 there as well. So my scale factor is 1.5. So that means I can then therefore say that it is the SSS, 3 sides in with the same scale factor. And so therefore, and we will label that triangle ABC is similar to DEF. Triangle DEF, so that's our similarity statement there. On the next page we have 2 isosceles triangles. So here we have our, again, sides given to us. So we're checking that we have the scale factor the same for those, and then knowing that that other pair is the same as well. So we've got a scale factor of 2 there, 5 going to 10, 6 going to 12. And then we know, because that is the same length, that that also has a scale factor of 2. So that's another SSS. And then the last one that I've got on my list to look at, I obviously haven't included one that has all the angles the same, because that's fairly easy to see. Here we've got 2 sides and an angle. So we've got our angle there. I haven't labeled any letters on here, so I'll quickly do that. I'll go A, B, C. And then I'm going to mix it up and go DEF, just to show you the similarity statement for this one. So we've got our angle C is equal to angle F. Then we've got that our Scale factor, we want to check what that is. So going from 10 to 15, 15 divided by 10 is 1.5. And then 16.5 divided by 11 is 1.5. So then we will say that our line AC to EF, scale factor equals 1.5, and then we've got BC to DF, the scale factor equals 1.5. So therefore, and this is where I need to be careful with my labeling, triangle ABC is similar to, and I need to label in the same order, so EDF this time, because of the side angle side. And as I said, if you were given the angles, that would be fairly obvious. The only trick they'll give you for that is if they only give you two of the angles and you've got to work out the third.